The Oregon Cattlemen's Association is committed to the principles and practices necessary for sound management of our natural resources. Our members are dedicated to sustainable beef production. The products we produce support rural communities and our state's economy. The Oregon Cattlemen's Association supports research to increase the efficiency and accuracy of monitoring the health of Oregon's rangelands. These techniques are promoted to livestock producers so they can better manage rangelands for the future generations. These videos explain monitoring methods for the collection of scientifically valid data for the evaluation of grazing management strategies. Ranching in the 21st century benefits both economically and environmentally from the knowledge we have gained about rangeland monitoring. Using sound management practices will lead to the sensible resolution of potential conflicts. We hope that you find these presentations both informative and useful. We encourage you to incorporate routine monitoring as part of your ranching operation. For more information and a monitoring guidebook, please contact the OCA office.
Ecologists have used photographs, both landscape photographs and photographs of experimental plots, since the 1920s in order to document conditions and trend on rangelands. Early ecologists also used a technique called pantographing, which was a means by which they could actually identify the location and the juxtaposition of various plants within a quadrat. These studies were important to document the change in the community over time in relation to various natural events such as drought or to managerial activities. These are extremely important vehicles by which ecologists can monitor ecosystem, and we've been trying to bring these into the 21st century. This is an image of a pantograph that was used on the Great Plains and was actually published on in 1920. As you might imagine, what we would do with this longer arm is trace around the base of the plant or a grass, bunch grass in the pasture, and then on the flat plane or the table, it would actually write the position of this in a scaled drawing. As you can imagine, this required an enormous amount of work and was done usually by students as well as by researchers in order to get a very good understanding of the dynamics in those particular quadrats, usually 1 meter by 1 meter. I think the fact that they were willing to invest so much time and effort in it demonstrates the value of these kinds of this kind of information in monitoring rangelands and in monitoring the direction that rangelands are moving. This image is actually two separate pantographs that have been put together. The top half and the bottom half actually represent different locations, but they represent the basal area of plants on the Great Plains. This was done by John Weaver and Fred Albertson, and in this case they're examining the basal area of these plants so that they could follow the effect of the Great Drought. Again, very valuable information when put in context of multiple years of study or multiple pantographs of the same plot. Basal area was typically measured, but you can also measure the area of the crown of plants. And this is just an example of a pantograph that was done for the crown of plants, again on the Great Plains. It wasn't long before people started using photography in order to replace these pantograph drawings, which took so much time to do. And the photography again proved to be quite useful. It was a lot more difficult to do then than it is now. But again, that just demonstrates the value of photographic charting. The photographic industry has been very kind to rangeland ecologists because over the last 20 years they've developed digital cameras that capture as many photos as you wish at very, very low cost. It's very easy now to transfer these photos to storage media and to duplicate that media or save the photos in other places. So it's much, much easier now and much, much less expensive than it was in the recent past to do photographic charting of rangelands. These images, the images, both landscape and straight down, can quickly and efficiently capture information about the structure of vegetation, plant cover, litter cover, the amount of bare ground, as well as information about invasive plants. It's really quite remarkable how much information can be gathered in a very short time period. In this video, we're going to outline a method for the capture of geographically referenced images that can be used to quantitatively monitor rangelands and determine if the photos are taken at sequential time intervals, range trend. To make our job of collecting information even easier, cameras are now built that have GPS capabilities, and the GPS can record the location of each photo that is taken. This is done directly in the image header file, and this means that you're not only able to record the photograph, but you're able to record the date and the time that the photo was taken, as well as the position or the place on the earth that the image was taken. GPS cameras now are quite common. There's a whole series of different models available. There's Canon cameras, Sony cameras, Nikon, Pentax, and even smartphones can be used as GPS devices that take photographs. The GPS information is written into the header file on the JPEG image, and so it stays right with the photograph and can be used very efficiently. One of the real problems with this for people who are celebrities is if they take photographs with a GPS enabled camera and they post that on the internet, the position where the image was taken is also available to people that open the image. So some Hollywood personalities have actually given away the location of their favorite getaways or their homes by posting images on the internet. So just a word of caution, if you happen to be a celebrity, you probably don't want to post these images on the internet. In this example, we're going to use the Nikon Coolpix AW120 camera. We could have used any of a number of cameras, and we don't mean to endorse this camera specifically. But this one is quite nice because it has a fairly high resolution. It's a 16 megapixel camera. It has vibration reduction, which has a tendency to make the images a little bit clearer. It has a fairly long battery life. You can shoot about 250 photographs before you have to swap out the battery. And as I mentioned, it does have a GPS tied with it, so it automatically can register the GPS location of the images. The Nikon Coolpix also is a fairly rugged camera. It's waterproof up to a depth of about 30 feet. It has a wide temperature range under which it functions. It handles shock reasonably well, and so therefore it's a good camera to use in the field because you can put it in your shirt pocket and not have to worry about whether or not it's going to be damaged at the end of the day. Not only does this camera have a GPS, but it also has an electronic compass in it, so it will tell you which direction you're facing when you take a landscape shot. And the other thing that's really nice about this camera is that the camera time can be synchronized to the GPS clock, which is synchronized to the national standards clock, which means that you're going to be able to record the time within about a microsecond of when the image was actually taken. So we don't have to worry too much about moving around. If as we take the photographs, they're going to be recorded in time very accurately. So now we're going to explore how to use this GPS camera for agroecological data collection in the field. The first thing to remember is to keep a spare battery charged all the time. So when we go to the field in the pickup, we'll plug in a battery charger for the camera and have a second battery that's charging while the first battery is being used. And as soon as the first battery gets low on electricity or charge, we're able to switch to the second battery. We typically do this by plugging the battery that comes with the camera into a power inverter. The amount of power is required to charge the battery is very small, so we can use a 100-watt power inverter in order to do this. You can actually buy the second battery or a spare battery along with a plug-in that is used in a cigarette lighter for about $20. And so it's relatively easy to get spare batteries for this unit, as well as the ability to plug it directly into the cigarette lighter. But the idea here is you have to always have a second battery charged. You don't want to run out of electricity halfway through the day. As we're headed to the field site, we will turn the camera on and allow it to obtain a GPS fix. What this means is that we enable the GPS option in the menu system of the camera, and we put the camera on the dashboard of the vehicle and just allow it to find itself. It may take anywhere from 5 minutes to 15 minutes to find itself, and we want to make sure that we get a fix, so we do that. We give it that time to get going. You can tell if it hasn't received a fix yet by looking at the screen. If you see a world map on the screen, that means that the GPS has not gotten a fix. It doesn't know exactly where it is. That will convert to a map when it does have a fix. So if you're in the field and you go to take a photograph and all you see is a generalized world map, you know that you have to wait until the GPS unit gets a fix before you can proceed. In this image, you can see that the GPS now has a fix and it's got us where we are in the world. That means that this camera now is ready to be used in the field to collect georeferenced photographs. The other important setting on this camera or any other is the image mode, and this is related to the image size and the image quality. And we set the mode to the highest pixel resolution the camera can collect, and the lowest amount of compression that is used with the JPEG files. These cameras typically collect in a JPEG format, and JPEG is a compressed format, and so what we want to do is have the minimal amount of compression so we maintain the maximum amount of information in the image itself. So what we want is low compression. This is 1 to 4, and we also want to have as high a resolution as possible. When you arrive at the site, there's a standardized protocol that you should follow in order to make sure that the information that's being collected or the monitoring that's done on this range site is as useful as possible. So we're going to go through a few steps that help you collect the proper information in the proper sequence. The first thing that we do is we take reference photos, which are close-up photos of all the identifiable plants on the site. This gives us a species list of what's there, and also gives us a reference image so that we know what the phenology of each plant species is when we're taking the photographs. This helps us later when we're identifying species in the photographs, because we'll know what the plants look like as we go through the photos and read them. This is important to be done every time you go to the field and every time you change sites. So there's a series of these close-up photographs, and those photographs typically we will identify the species as we move through taking the photos. So we'll write down image number 1 was such and such a plant, image number 2 was blue bunch wheatgrass, so or whatever it happens to be. So this gives us reference images that we can look at when we're reading the plots. We typically focus on a single plant in these reference photos and have that plant identified as we move through. So these really are quite useful. For the trained ecologist, or botanist, these images hold a lot of information. So we can identify not only the species, but we can see at what stage these plants are. In this particular image, it's relatively early in the spring, and you can see that many of the plants are just emerging and have not developed very much. But this allows us then to see in great detail each individual species on the plot. Once we are ready to actually collect our quadrat data, we have the camera mounted onto an apparatus shown in this photograph, which consists of a bubble level, a compass, a GPS camera, a camera head, and a monopod. The compass and the bubble level are mounted on the camera head so that when the camera is facing straight down, the bubble will be in the center of the bubble level, and we can determine the direction that top of the camera is pointing from the compass. This apparatus is relatively inexpensive. We use a Bogen Manfrotto monopod and camera head. The camera head is called a junior camera head. In this apparatus, the little platform itself and the bubble level and the compass are easily fabricated in the shop. We have a hole through this piece of plywood that holds them so that they can be attached to the camera head along with the camera. The next thing that we do is we set the camera zoom to as wide an angle as is possible, and we try to hold it at that wide angle position so that all the plots that we take photographs with will be the same size. The second thing that we do is we adjust the camera head and the camera position on the head so that the tip of the monopod is just outside the field of view of the camera, and we lock that in place. And the reason we do that is so that we have the position of the plot on the ground is going to start just in front of where the camera monopod is placed, and in this particular camera at about 1.5 meters, what we're going to have is the size of the image on the ground of about 2 meters by 1.5 meters. So this allows us to set a standard quadrat size, so as we go across the landscape we can tell where our plots are going to be. The other thing that we do is we take photographs in the 4 cardinal directions, and this is done so that we have a general idea of what the landscape looks like, what the slope of the land is. We can tell, what the dominant vegetation is across the landscape, and other things about the general view of the landscape. If there's other objects close by that are going to affect the site. So these are quite valuable in photographs and should be recorded every time that you sample a site. Once the camera is on the camera head and ready to be used, we level out the bubble level with the monopod extended, and we measure the height of the camera above the ground. the height of the camera above the ground and the focal length of the camera tell us then how large an area is being sampled. This is very critical that we collect this information because we have to know how high that image is above the ground in order to scale the image properly. When the steps just outlined are completed, we are ready to start collecting data. In the first image, we typically put a ruler on the ground so that we have a verification of the scaling, and that ruler will be able to see in the photo when we get it back, and after it's processed we can measure how many pixels that the ruler consists of from one end to the other and actually determine if our scaling is correct. The other thing that we do is we, in the northern hemisphere, always take our data collection with the top of the camera pointed southward. And we do that to minimize the amount of shadow in the image and to maximize the amount of information that we can see. Deep shadows are going to mean that you're not going to be able to see clearly what's on the ground. So to minimize those shadows, we face south. Obviously, if you were in the southern hemisphere, you'd want to face northward in order to minimize the shadow. Once you're in the field and your camera has a GPS fix, the tripod height has been measured, the camera itself is adjusted on the camera head so that the image does not include the base of the staff. You're ready to collect images. You can do this very, very rapidly as you go across the landscape. You should always make sure that the camera is facing to the south so that the amount of shadow in the image is reduced, and you have an easier time later interpreting where the plants are and what the plants actually, which species actually are in their plot. A lot of data is automatically saved along with the image by these cameras that have the GPS. So in this case, automatically saved in the header file of the JPEG image that we're taking. We have the dimensions of the image in terms of the number of pixels. We have the camera make and the camera model. We have information about the focal length that was used. We have information about the latitude, the longitude, the altitude above sea level, the date and the time that the image was taken. All this information is automatically collected, and so you really don't have to do anything in terms of recording on a separate piece of paper or anything like that. All of it's done automatically, and all of it is quite useful. This is an image that was taken with a wide angle lens, so the zoom factor was set as wide angle as possible. You can see that the angle of the camera on the camera head was not quite set correctly, because we can see the base of the staff in this image as well as the feet of the researcher. But it gives you an idea as to the relative size of the plot that's being collected, and also the relative amount of information that's available in this plot. If we zoom in a little closer on this particular plot, what we can see is the detail that's available. So there's information about the stoniness of the surface, the relative amount of litter on the ground, the amount of bare ground showing, as well as the relative size of the plant species that are growing in the plot. Once the data collection for the site is done, and the other sites have been visited and data that's been collected on each of those sites are acquired, we go back home, we save this information on a hard drive. Oftentimes we'll back that information up so that we have a secure data set, and then we're able to view these images on the computer. And as I mentioned, because the date, time, and position information stays with the image, wherever that image goes, if it's saved in another location, all that data goes along with it. The images can be marked permanently with burned-in lines that give a certain scale on the image. That's done with specialty software, which we'll talk about in another information series. But as I said, these information, or this data set, is now secure, and as long as it's backed up, the quality on the images lasts for as long as your computer can read them. So it's a pretty amazing, fast way to collect much detailed information very, very rapidly. This is an example of the kind of information that can be gleaned from photographic data sets as outlined in this video. This is a second flat location in the Burns District of the BLM, and it was examined for the relative amount of annuals versus perennials, and then within the perennial component, deep-rooted, moderately rooted, shallowly rooted grasses, forbs, and shrubs. And you can see that across this site there were only 4% of the plots that actually had annuals in them. So the annual grass presence here was very low. The perennials were found in all of the plots. We had deep-rooted perennials in 34% of the plots, moderately rooted, moderately deep perennial grasses in 60% of the plots, and then shallowly rooted perennial grasses like Sandberg's bluegrass in 74% of the plots. Forbs were found throughout the area. 70% of the plots had forbs, and there were no shrubs encountered. If you look at the plants per meter column, you can see that we were able to determine how many deep-rooted, moderately deep-rooted, and shallowly rooted perennial grasses there were in this system in terms of the number of plants per square meter, the relative number of forbs, and you can see from this that this is a very good range site. We don't have very much annual invasion on this site, and it's got the presence of deep-rooted plants, deep-rooted grasses, as well as moderate and shallow-rooted grasses. So this is quite a healthy site, and that's all derived from the information that was captured in the photographs on the site and then analyzed by an ecologist.
Data forms and more detailed information can be located within the Oregon Resources Monitoring Guide, the Rancher's Guide to Improved Grazing. It is published by the Oregon Cattlemen's Association and is a valuable tool as a reference material.